Welcome to Coach Eichner's Math. Today we will be talking about triangle basics. To start off, we're talking a triangle. A triangle is a plane, closed figure formed by three segments joined by three non-collinear points. Got three non-collinear points, which gives me three segments, and the plane is enclosed. There are no gaps, no holes. So, looking at it, my points are also known as my vertices, or the corners of my triangle, which would be point P, point Q, and point R. The sides are also known as segments, would be segment PQ, segment QR, and segment RP. Remember, on segments, I could write PQ or QP, and it would still be the same. There's no difference there. Looking down below, we want to classify triangles by the length of its sides. This is one option we have. So, as I'm looking at it, a scalene triangle has three different lengths. Notice I'm putting one tick mark on one side, two on another, and three on another. That's a way to denote that those are different lengths. An isosceles triangle has two that are going to be congruent, and I would put two tick marks down here because the base would not be congruent on an isosceles triangle. Whereas an equilateral triangle has the word equal in it. All my sides are going to be equal. All three sides are congruent. So look down at example 1. Using the sketches drawn above, go ahead and classify each of the triangles by their sides. I'll pause now, give you just a moment. A, we should have said, was an equilateral triangle. B, I would say, is a scalene triangle. And C, I would have called an isosceles triangle. All based on the number of sides in my picture. So, looking on, the sum of the measure of the interior angles of a triangle is 180 degrees. This may be the most important thing in these notes to make sure you retain. Circle it, highlight it, do what you need to make sure you go back and see it again. The sum, adding up all three interior angles of a triangle, I am always going to get 180 degrees. The triangle can also be formed by the measure of its interior angles. So, these I'm just going to sketch on the spot here. An acute triangle would be a triangle that has three acute angles. An obtuse triangle would be a triangle that would have an obtuse angle, such as right here. A right triangle would be a triangle that has a 90-degree angle. And an equiangular triangle would be identical to the triangle that we had right here. We'll talk about this more detail later, but an equiangular triangle also has equilateral sides. So, equiangular and equilateral are the same picture because they will be one and the same. We will get more into detail on this later. So, looking down below, example number 2, classifying by my angles. Got three congruent angles, makes it an equiangular triangle. Got three different types. Got acute because they are all less than 90 degrees. Got an angle greater than 90 degrees, makes it an obtuse triangle. And our other option is our right triangle. I know it's a right triangle because it has a 90-degree angle. So, looking down below at example number 3, find the measure of the third angle of a triangle. If the first angle has 66 degrees, second angle has 37 degrees. So I'm just going to go ahead and sketch myself a triangle and say I've got 37 degrees and 66 degrees. It doesn't have to be to scale, but 37 and 66 I'm missing. We'll go ahead and call it angle A. I'm missing angle A, but I do know, if we go back up to the top of the page, that those three angles have to add up to 180 degrees. So I can say 37 plus 66 plus angle A equals 180 degrees. Well, that's just 96, that's 103 plus angle A, and really I should be saying the measure of angle A equals 180 degrees. So the measure of angle A, after I subtract 108 from both sides, would be 72 degrees. Pretty simple. So that is one of the most important things we'll be talking about as we're going through our triangles. Looking at the next one, they're going to use that same concept and have you take advantage of the fact that we know they're 180 degrees. But this time they don't tell us the exact measure, they just put a variable there. Lucky for us, I can say that angle S, measure of angle S, plus the measure of angle R, plus the measure of angle T, equals 180 degrees, based on what we looked at earlier. So S is X, R is 3X, and T is X plus 40, and that's going to equal 180 degrees. Well, I'm going to go ahead and combine my like terms. The stuff on the same side of the equal sign can be added together, which gives me a total of 5X plus 40 equals 180. Subtract 40 from both sides. 5X equals 140 degrees. Divide by 5. X would equal 28. Now, looking back at what we're asked to find, we're asked to find the measure of each angle, not X, but the measure. So plugging it back in, X is 28, so S is 28 degrees. R is 3 times X, or 3 times 28, which would end up being 84 degrees. T is X plus 40, which would be 28 plus 40, or 68 degrees. Now, when you add all three of these together, you should get 180 degrees. If you don't, you've done something wrong. So let's look down below. Find the value of X in example 5. Well, we know that, same as before, the measure of angle S plus the measure of angle T plus the measure of angle R equals 180. This time that's saying X plus X plus X equals 180, or 3X equals 180, which means that X would be 60 degrees, which would make sense because every equiangular triangle, remember equiangular means congruent angles, every equiangular triangle will have 60 degrees for their angles. The triangle in example 5 is equiangular. Based on this example, we can say that each angle of an equiangular triangle is 60 degrees. So, let's look down below. Find example 6. Find the value of X. Remember that this is 90 degrees. And I want you to pause the video and see if you can come up with what X would be. And then when you're finished, unpause the video and go through it with me. I'm going to say that the measure of angle J plus the measure of angle L plus the measure of angle K would be 180. Why? Because that's the rule. Angles of a triangle are always going to add up to be 180 degrees. So, measure of angle J, 3x plus 2 plus 2x plus 3 plus 90 equals 180. Going to combine my like terms on the same side of the equal sign and say 5x plus, there's 5, there's 95, equals 180. So 5x would equal 85. I'm going to divide both sides by 5. I would say that x would equal 17. Pretty simple. just some algebra thrown in there. Angle J and angle L in example 6 would be classified as acute angles. We would know they're acute because there's 180 degrees total. And since there's 180 degrees total and 90 of them are taken up by angle K, the other two must sum to be 90 degrees. So we can assume that the other two angles are going to be acute angles of the triangle. In this case, we can talk about that fact that acute angles of a right triangle, the two that are not involved in my 90-degree angle, will always be complementary. Remember, which is just a fancy way to say 90 degrees. So looking on a little further. Now instead of talking about interior angles, we're going to talk about exterior angles. So talking about an exterior angle of a triangle, it's formed when one side of the triangle has been extended to create an exterior angle, like in example 7. To find the measure of the exterior angle, add the two remote interior angles. So, really quickly, I want to go through and prove this to you. The measure of angle 1, based on what we're talking about, it says add the two remote interior angles. The remote angles are the two not touching my exterior angle. 40 and 80 would give me 120 degrees. But now let's look at why that is the case. We already said that all three angles, the measure of angle D plus the measure of angle F plus the measure of angle, we'll call it angle 2, equals 180 degrees. I'd agree with that because we know a triangle is 180 degrees. So watch this. I can also say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Because the measure of angle 1 and the measure of angle 2 make a linear pair. So if they both add up to 180 degrees, I could tell you that the measure of angle D plus the measure of angle F plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 2. To make this long story short, at this point I can come in here and I can cancel out angle 2. It's on both sides. So when I rewrite it, the important thing to know is my exterior angle, the measure of angle 1, equals the two measures non-adjacent, which in this case is angle D and angle F. So, looking down below, this is important for us to see. Example 8. Measure of angle X is 63 degrees. The measure of angle Z is 64 degrees. So based on our rule, 63 plus 64, okay, that's 127 degrees. That would be my exterior angle. They asked me to find the measure of ZYR. So 63 plus 64, 127, that would be my answer, 127 degrees. Now to check my work, I know that XYZ and ZYR are supplementary, so 180 minus 127 gives me 53, which means that this must be 53 degrees. Well, if I take that 53 and I add it to my 127 that I got from 63 and 64, I'll be back at 180 degrees. And we know that a triangle is always 180 degrees. Great way to check your work. Looking at example 9. Last example, go ahead and pause the video, take a moment. As soon as you're done, come back and we will talk. This one's just going to take a little algebra. So as I'm working through it, I would say that it is 19x plus 2 equals 17x plus 10. Subtract 17x from both sides, minus 2 from both sides, and I would say that 2x equals 8 or x equals 4. Appreciate you watching and hope you have a great rest of your day. Just take that 4 and plug it into angle F, and you will have your